I'd like to take a moment and hand the baton over to my colleague, Michael Bilyeu, who's going to talk about our next segment for now.
Thanks, John. So we're going to continue with the mobility theme for this next section. One of the key components to autonomous transportation, as well as the future of AI applications, is going to be image recognition. Not only from a vehicle perspective, we see that as a common foundational component in the autonomous vehicle itself, but eventually it will interact with the infrastructure itself. We could think of how the image recognition could feed a model to improve the vehicle or pedestrian safety as they walk along the sides of the road. Another key component that these models could use is for managing assets. Think of a real-time view as asset locations, which can play a vital role in sustainability to come. So with that, I would love to introduce Daniel and Carmen from our partners Wovenware. They are currently developing this exact technology.
Hello, everyone. My name is Daniel. I'm here with Carmen, and we would like to talk to you a little bit about, uncovering the potential of computer vision at 5G speeds, and so basically what all that entails and what our experiment is all about, right? So if you could please give me the next slide. So the technology that we're using and working with is basically geospatial artificial intelligence. And it's technology that gives us a lot of practical functionalities and uses on our world today. So I would like to give you some examples. For example, if you go to the next slide, we could, if you're a retailer or you are an economist, you can actually measure the activity of your retail complex, your mall, your store, by measuring the parking spaces, how people are moving through different times of day. You can also follow trends. For example, we know that with the whole COVID pandemic, we can see that how the shopping and the buying trends of people have changed through time. So we can have a good look at that. So also we could go to the next slide. We could see that for governments, we could use this technology to track airplanes on airports and ships on the sea. So basically we can ensure that our security and safety and the security of our shores. And there's another slide. If you're in the insurance, industry, let's say you have a house that you need to basically know how you're gonna, build that and what policy you're going to apply to that, and even measure liability for that house. You can do that from your office now with this technology. Basically, you can see where it's at, measure the measurements of the building, and so forth. And this technology basically gives you all that practical uses and data, so make better decisions for your clients. So the good news is that if you go to the next slide, we can see that the good news is that with time, as this technology advances, the resolution of our images are getting better. So right now, we can go, we're working at 30 cm resolution, but we can bring that to 5 cm eventually. What that means is that, yes, we can actually identify that we can see cars in a parking lot. But eventually we'll be able to say, oh, that's X or Y brand, and we can know which kind of cars we're talking about. So that data can be really useful for us in the future. But with those advantages and that advancement in the technology, the truth is that we also have challenges. So let's see what I'm talking about on the next slide. Because the truth is that with better resolution, it's basically we have higher data rates and it's heavier images that we need to move from one point to the other. So basically that's our biggest challenge. As this technology advances, we need our networks to move forward with the technology as well. So that's basically what we're going to find out. We want to know, and that's what the experiment is all about, just to find out if the speeds of 5G networks can actually have a significant impact. Sorry, could you move to that next slide? So there you go. Sorry, my bad. So if the 5G networks can have a significant impact, not only moving heavier data and more resolution, but also being able to serve people in remote areas. So that's what we want to find out with our experiment. So let me show you what we're gonna be working with. So if we could move on to the next slide. Basically, what we're doing is that we have an application on a mobile device. So we have an image, and we're gonna be moving that images in small tiles to our server, which basically is a server that we put up, and that server has a neural network which has hosts a model that basically processes that images. And in this case, we train that model to spot buildings, right? So they will identify the buildings and send us back the data to our application. I will draw little green, little boxes on our images just to, identify those buildings that the model have found out. Sorry. Okay, so basically we're doing that. If we move to the next slide, that would be our workflow. So we have our data. We do uploading the images through the 5G network back to our model server. Then it will process the images and send back the response with the results of our data. And then we'll actually do some metrics on that data just to see, how the round trip times, how did that behave compared with 4G LTE network. So let me give you an example of what we have as a baseline on the next slide. Basically, we have run this test with 4G network, and our average times through 6 experiments. You can see 6 different bars in this graph. So basically, we run the experiment 6 times. On the average time is basically around 33 seconds for the round trip. So we want to find out how does the 5G network behave and compares to these baseline numbers. All right, so let's see it in action.
What we're seeing here and what we're excited about is that we designed this experiment to really test the upload time, which we know is the biggest limitation right now, or one of the limitations with 5G, but we really wanted to test the boundaries and see how it behaved compared to other networks. We are really sending the heavy, big images over the 5G network. And still with that, we're seeing that the speed is improving greatly. And we're excited that as we get better resolution images and as we get this promise of ubiquitous connectivity with 5G, that we're going to be able to do a lot with different use cases and applications of this.
Awesome. Well, thank you, Daniel and Carmen, so much.